Awesome. So, welcome to Conf. We're doing the first B-Sides talk. I'll be talking about the job inspector. So, you'll learn what your search is doing, what it's spending time on, where it's actually running on your Splunk environment, whether it's doing stuff on the indexers, how well distributed it is, whether it's doing lots of work on the search head. We'll dive into that, and if you've got any questions, just shout out, let me know. I'm not going to say I was too lazy to prepare enough content. Feel free to ask questions. I've got a couple of examples prepared. So one thing you would often do is you would count by some field and maybe do some evals. The actual search doesn't make sense. It's just an example. So what we can see when we enter the job inspector is a couple of things. We've got the view of how much time did each command spend and how often was it run, so how many events did it touch. And down here we've got properties of the job. There are a couple of properties that are really important. One of them is the scan count. It's up here. This will tell you how many events did Splunk actually load off disk. So if this is a large number, Splunk had to touch a lot of data. It doesn't necessarily have to be good or bad to be large, but if you expect to touch 100 and it's touching 100 million, something's going wrong. You can look at the event count, which is telling you how many events actually matched your search. So stuff that was loaded off disk and was actually necessary. If there's a huge imbalance between these two, you're probably doing something wrong with regards to your filtering. So if you've got some wildcard filters, for example, Splunk can't optimize those. If you've got some not field equals value, there's no way to optimize those. I've got a whole full-hour talk on that in Conf 17 and 16. Check it out. It's fields, index tokens, and you. If you want to know more about event count and scan count and lispy and loading stuff off disk. This is just where you can find it, whether your search is efficient in that regard or not. Another thing you can find down here is which part of your search was actually distributed down to your indexers. So if you're familiar with MapReduce, Splunk will run a map function on the indexers, return a pre-computed result, and the search head will reduce all those results together into one final result. And when you look for remote search in here, you see a slightly different syntax than SPL, but it's really similar. So instead of my search index equals internal, it's got a lit search. Just think of search, ignore the lit part. Then you've got the eval. So the eval is running distributedly on the indexers, which can be good. It's adding some stuff to my fields, and it's doing a preliminary result for my stats. In this case, I'm counting by a field. So each indexer will count for the field values it knows, return that count up to the search head. So it's not returning raw events, it's returning pre-computed counts. And there is a reduce search and a report search. This will be what the search head runs on those pre-computed results. So whenever you've got a list of counts from one indexer and a list of counts from the next one, this will collate up the counts into one final result. So from a MapReduce point of view, this search is pretty good. It's doing as much as possible on the indexers, because when we look at our search, basically everything's happening on the indexers. If we imagine a little pre up here, and nothing happens afterwards. So from a parallelization point of view, we're good. When we look at the performance part and check out the eval, we see that our simple eval took quite a few seconds of time and it ran 35 million times, which is quite a lot. If we change our search around a bit, if we just cut that out and put it here, we will now move it to the search head. That's bad because we don't run in parallel. but in this case it's good because we're running on way fewer events. And when that actually finishes, we can see that the count for eval in the job inspector will be way lower. And whether you should do this or the previous one depends on your search and your environment. If the stats reduces your number of rows down by, like, say, times 1,000,000, you will always want to do this. If it reduces your results by a factor of 2, but you've got 100 indexers, the first one will be better in terms of finishing faster, because each indexer will do twice the work, but it will be spread out over 100 indexers, so you're 50x better than doing it on the search head. When we just check out the job inspector, we should see eval somewhere. Where is it? So it's doing some previews, running over and over, but we're nowhere near the number of events that have gone through by now. And when we look at the runtime, it's basically nothing. Compared to the actual loading of data, it's not saving that much amount of time. But as a general principle, think about where in your search you're running a command. If you're filtering, you usually want to filter early. If you're doing computations, it depends on where the most reasonable point for that is. I've got a more extreme example. When we try to resolve IPs, for example, resolving them takes a lot of time. I've actually masked the hosts because it's real data. So you see nonsense down here. When we look at the lookup, it's taking basically a minute just to run that lookup, doing lots and lots of DNS queries, 37 million times, roughly. And I've run this one prior. It's basically doing the same thing, but it's counting by IP, not by host. Then it's doing the lookup on the reduced stats. So it's not doing the lookup on the indexers, which is bad, but it's doing the lookup on a tiny set of results, which is good.
Is there a way you can pre-stats it? So that each indexer does it?
No, because once an indexer does a stats thing, it will return to the search head, at least while you're in stats. In tstats, you can do some magic stuff, because tstats has a pre-stats equals true mode. Then you can do a lookup, and then you can do the final stats and return it back to the search head. But you can only do that on the group by fields in tstats. You cannot do that on the actual function results of the tstats, because for the group by fields, the value is known for each indexer. If you're grouping by an IP, that IP is known. It's not going to change on the way up. If you've got, for example, a count, the indexer doesn't know the final count, so there's no point doing an eval on that count on each indexer. It's always the question of, do I have the entire information or do I not have that? And for group by fields, the indexer has enough info. For some functions, it doesn't. When we look, we've got 29 invocations for a whole second. So basically, we've saved a minute of search time and a lot of DNS load. So your admins will love you or hate you, depending on what you do. There are docs, obviously. You should check them out. Over the past years, they've improved quite a lot. They will give you a long explanation of all the stuff that's in there. I only have covered like this much so far. There's lots and lots of more stuff, especially if you've got, for example, some safe searches running as an alert. There will also be a blog about the safe search object, as well as the job itself. So you can see which safe search was it, what was its configuration, and then what was the result of your job, the different parameters for the performance, for example, what ran where, everything we've been looking at just now. I'll take that opportunity to get any questions if you want, before I dive into any different topic. It's your opportunity to ask questions.
I have another totally unrelated question for you at some point.
Go ahead.
It's totally unrelated.
Okay, then we'll do that later. Right, so what we can look at is the scan count, for example. We're counting by file, which is nice, but we're not actually telling Splunk only look at stuff that has a file. So the intuitive way would be to tell Splunk only give me events that have a file field.
Repeat the question so people can hear.
What will happen now is Splunk will still scan the same number of events. We had many millions before, and we still have many millions. Because a wildcard filter like this doesn't have anything Splunk can work off. So it doesn't have any string, it doesn't have a source type, it doesn't have an index, a host. Everything that Splunk can know about the event that tells it does it have a file field or not can only be answered once the raw data has been loaded off disk, all the fields have been extracted. So our scan count, which is this value, it's also in the job inspector, it doesn't go down. So it's a nice try, but it doesn't actually work.
Is there a reason that they can't add that? I mean, if your transforms or your props configuration contains those extractions with the field names, could someone not think ahead and go, well, we know what the field's going to be because we've got the regular expressions for it. They could potentially make this faster, right?
Yeah, question for the people watching the stream. Couldn't you do that faster if you've got the props and transforms in place?
At least by source type.
And you could. It's called index time fields. If that was an index time field, like for example host, that kind of filter would be fast. If you're defining them yourself, there are quite a few pitfalls. So for example, you have to define the fact that it is an index time field in fields.conf, which is not scoped to a source type. So if I define file to be an index time field in fields.conf, it will be an index time field for every source type, even if that source type doesn't actually extract it at index time. So it will break search for those source types. So you have to be really careful about using index time fields. What you can do is, if you know your data, you know that all this stuff is basically access logs. In my mind, I wanted to look at access logs when I wrote that. Which file is being accessed? So if I filter for those access logs, the scan count will of course go down. And I want to get all access logs, so anything with access in it. And if this were a search time field, the leading wildcard would be terrible for Splunk. But since it's an index time field, a default one, this search will be fairly smart. And every time you see these two numbers, I will just run it again so you can see it. Anytime these increase basically roughly at the same speed, then you're in a good space. It was much faster, obviously, but the point is to see the relationship between scan count and event count. So when we look at our data down there, we see event count is 85K, and our scan count is also 85K. So every event we loaded off disk, we actually need it for our search, which is the ideal scenario. It also ran much faster, but there are some source types in internal that also have a file field. So we were looking at more data before. But if you actually want to look at access logs, filter for access logs. Filter as early as you can. That will help your search in any way imaginable. Okay, we still have a couple minutes of time. I was hoping for quite a few more questions. But what we can do is we can grab a couple more of these properties, or rather of these performance values I look at quite a lot. So for example, you see this little area down here. That's a bad example. I'll try to run a bad search. Let's say something like this. Let's just count it. And let's use a lot of time, which you never do in your environment.
People like to do that.
What I want to trigger is that lots of actual I/O operations are happening. And I want to see, is my I/O performing fast or not? And for this, there's a little histogram in here. It's printing out the number of I/O operations by the time they took in microseconds. So anything below 8 microseconds basically came off cache. Anything below 64, same one as well. And from these values on, you're looking at SSDs probably. And anything bigger than like 8 milliseconds will be traditional spinning disks usually. And
What did you say this one was again?
these are usually SSD values, and these are mostly coming off cache.
So what's the number represents? What does the number represents in that?
That's microseconds,
Right.
8 to 64.
Oh,
And
that's
in the
range.
bucket 8 to 64 microseconds, there were 1.4K IOPS happening. I'll just refresh that. 2.7 once the search is actually finished. So that instance Splunk is kindly hosting for me appears to have fast storage. You could have, for example, 32 milliseconds to 200 something. It's always increasing by a factor of 8. If you see those quite often in your environment, you probably have slow storage.
Oh, sorry.
Okay. More stuff happening in here. You can define knowledge objects in your search, doing evals or regexes or whatever, but you can also configure them to always be applied to your source types. So, for example, if you have lots and lots of calculated fields and the time spent on that is huge, you should look at how efficient are your evals. If you have lots of time spent down here in typer and tags, you probably have a huge number of event types defined. Most common example would be enterprise security, where you have lots and lots of common information model normalized data sources, where each data source might have a dozen or two event types. And anytime Splunk runs a search, each event has to be matched against every event type. The recent versions have started to become more smart about that. The keyword there is conditional tagging. It was announced at last conf. Yeah, it's mostly relevant when you're running your data model accelerations. You can tell the data model which tags are actually relevant for that data model.
The index
And
constraints, or is it another level beyond?
it's not the index constraints. The index constraints will tell the data model to only look at this section of your entire data set. The conditional tagging will tell the data model to only apply tags for, say, authentication. And that will skip lots and lots of time spent down here applying event types and then calculating what tags are matching for your events, which will make your data model acceleration run faster, which will lower your overall system load for ES, so you can do more stuff or add more users, add more data, more use cases, depending on what dimension you want to grow in, or all of them. Anytime you do less work, you can add more data in. I've seen environments where these were the majority of time spent for regular searches, if there are hundreds and hundreds of event types.
Your 1230s here.
They're probably running the Windows and
Yeah.
Cisco TAs.
Okay, so my next slot is here, so I will have to cut at this point. Thank you for listening. If you have any questions, just poke around the community lounge. Anybody with a FAS will help you in some way. Thank you.
Well done, Martin.
Thank you. Thanks, buddy.
And I will just log out of here. And that silly search is still running.
Just leave it. Background didn't go.
Nope.
Was this Job Inspector or was this whatever Martin feels like talking about?
It was what